My name is Julie, and welcome to our webinar today, SAP Predictive Analytics, the power of predictive in the hands of everyday business users. First, you'll hear from Rob Jerome, Vice President of Innovation and Technology, and then from Senior Consultant Georgia DeCruz. If you have any questions throughout the presentation, you can submit them using the Q&A dialog box. We'll be answering questions after the presentation and demo. And now I'll hand things off to Rob.
Thanks, Julie. Can everybody hear me okay?
Yes.
Great. Well, I appreciate everybody joining our webinar today. It's the next webinar in a series of webinars that we're doing associated with advanced analytics capabilities from SAP. My name is Rob Jerome, and I manage the database, data management, and analytics group here at Dickinson and Associates. And one of the areas of focus, obviously for us, just like for many organizations, is predictive analytics. Our goal in the webinar today is really to demonstrate how predictive analytics applies, A, to all industries, but B, today, really to less of the data scientist and more of the everyday regular business user. Traditionally, predictive analytics required complex algorithms built by data scientists working in large organizations, and the algorithms were run and the models were reviewed and the models were changed. But today, it's a very different dynamic. So leveraging SAP's predictive analytics solution and SAP's HANA technology, really all of those things that were done behind closed doors by teams of data scientists are really being done today by end users and business users. So our focus today is really going to be on that, on the software, and we're going to do a demonstration that outlines really a day in the life, if you will, of a business user using predictive analytics. With that, I'll hand over to George DeCruz. George is a senior consultant with our organization who specializes in predictive.
Thanks, RJ. Hello, and welcome to this webinar on SAP Predictive Analytics, Advanced Analytics with SAP HANA. My name is George DeCruz. During the past 10 years, I have worked on various projects delivering analytical solutions for businesses. What attracts me when it comes to analytical solutions provided by SAP is the foresight applied while laying out the platform for innovations and better technology solutions. And hence, I'm particularly excited that SAP is working aggressively towards bringing advanced analytics onto one single platform of the HANA appliance. We will begin with an introduction to SAP Predictive Analytics and understand how SAP Predictive Analytics delivers value for business. We will go over the architecture and integration with SAP HANA and demonstrate the capabilities of SAP Predictive Analytics with a system demo using algorithms from the SAP Predictive Analytics library within the application function modeler. Predictive Analytics helps connect data to effective actions by employing a variety of mathematical and statistical techniques for data mining, machine learning, and modeling that analyze current and historical facts to make predictions about potential risks and opportunities before they occur. What you see on your screen are various mathematical algorithms and statistical techniques available for use with SAP Predictive Analytics. These have been carefully chosen for their popular and effective application in industry. According to Gartner's chart from a few years ago, predictive analytics has proven itself further than all the emerging technologies on the list, and it is still growing with more and more companies investing in developing their advanced analytical capabilities. There is an imminent need in the industry to move from traditional analytics to an approach which is more on predicting what will happen in the future and act today, thus moving from sensing and responding to predicting and acting. Predictive analytics brings in increased maturity with advanced analytics and empowers you with greater level of insight for interpreting your data to optimize your business. Predictive analytics has a wide range of industry applications, such as in healthcare, to predict likelihood of diseases, to begin early treatment and identify clinical trial outcomes. In the banking sector, to improve credit risk analysis, identify key customer behavior, and prevent customer churn. In marketing, to identify potential leads to get the most out of your marketing campaigns. In the retail industry, to identify buying patterns and make product recommendations to determine commodity pricing for maximizing sales revenue. In insurance, to identify unusual transactions for fraud prevention and rate or score the risk that is to be insured. And in manufacturing, to employ preventive maintenance in order to improve machine utilization. So how does SAP Predictive Analytics deliver value to business? The business value with SAP Predictive Analytics are rich pre-built modeling functionality. SAP provides an extensive library of statistical and data mining techniques which popularly are known to be used in the industry. These techniques are pre-built and are available for use out of the box. Ease of use. With the drag and drop interface for data selection, preparation, and processing, with the ability of calling predictive algorithms through basic SQL scripts, you can reuse existing talent from within the organization and bring them up to speed and running with the tool. This also significantly reduces cost of training and the learning curve that follows after introducing advanced technology solutions. Extension with R integration. SAP Predictive Analytics supports integration with R open source environment, which provides the ability to use R algorithms. R scripts can also be embedded within SQL scripts and procedures within HANA. Unified platform. Now, SAP Predictive Analytics integrates with SAP HANA, which can also be used as a platform for operational and analytical reporting. SAP in its foresight has placed predictive algorithms and data within a single system environment, eliminating the need of investing separately to maintain multiple systems. You have one single platform which integrates operational and analytical needs with the ability to extend as you add more and more applications to your IT infrastructure. Speed and efficiency. Predictive Analytics calls for processing of massive amounts of data run through multiple iterations to arrive at a reliable model and at better predictions. Considering the huge volumes of data being generated from multiple sources with unprecedented speeds and the need for faster decision cycles within organizations, SAP Predictive Analytics with HANA as a database built on an in-memory technology employs a columnar approach while storing data with multi-core massive parallel processing. This improves performance considerably and overcomes the bottleneck between CPU and disk, thus enabling processing of huge amounts of data in seconds. Access data from any source. SAP Predictive Analytics is flexible to connect to any data source, whether it's an enterprise system, a data warehouse, or any data mart, spreadsheets, or Hadoop environments. And to close the loop with enterprise-wide reporting, there are rich visualization reporting tools with SAP Business Objects which connect directly to SAP HANA, where predicted results are stored along with transactional data. You can thus empower enterprise-wide users with anytime, anywhere access to key insights and drive business decision-making. Here we have the laid out architecture and integration in terms of the single unified platform provided by SAP with SAP Predictive Analytics on HANA. As spoken of earlier, Predictive Analytics with SAP HANA combines the speed and the depth of in-memory analytics with the power of native predictive algorithms that sit side by side within the same database. This improves efficiency by eliminating the need for maintaining different data stores, which repeatedly transfer data to and from predictive applications while performing analysis. SAP Predictive Analytics with HANA can connect to any data source you want. Enterprise-wide reporting solutions with SAP Business Objects and other tools is made possible. And we also have the integration with R. In the previous slides, we saw the various algorithms made available with SAP Predictive Analytics. We will now consider one such algorithm called naive Bayes. Naive Bayes is a classification algorithm based on Bayes' theorem. It estimates the class conditional probability by assuming that the attributes are conditionally independent of one another. Well, put into mathematical equation form, it looks something like this. As a business analyst, you would say, well, this may make sense to a data scientist, I guess, but what does it mean to me? Let's take a look at how SAP brings these mathematical and statistical computational methods to work for users who may not fully comprehend the math behind it. I have historical data on leads from previous marketing campaigns held at various locations at different times of the year. This data provides me information about who was contacted. Was he a decision maker like a vice president or a person who makes recommendations for products or purchases like a product manager, or was it an employee who was just curious about knowing our product and offerings? The location of the company. This factor is to align with the focus a particular organization has in terms of targeting growth in a particular region. We have data on the industry for the organization, the estimated size of company quantified by revenue in dollars, motivation to buy. Now, this could be ranked by a salesperson based on their interaction with the customer. He or she would provide ratings like unsure, likely, very likely, and so on. The information on budget set aside for purchase is also acquired or estimated by a sales personnel from their sources available to them from their interactions with the customer. This rating is of importance because the preference would be to reach out to the higher budgets first. Activity level, whether it was an initial conversation, a product demo, or an on-site visit. Was it a referral presented by a binary, in this case, a 1 to state that it was a referral and 0 otherwise? And at the end, we have the sales conversion column. So this is historical data, so it has a yes or a no to identify leads from previous marketing campaigns which turned out to be our customers or not. And now switch to the screen, which is right now what we see in front of us is the HANA Studio environment, wherein on the left-hand side, you have your data in tables available. And on the right-hand side, if I move over here, I have all my algorithms available here for use. In this case, we are considering the naive-Bayes algorithm. We have the train model and we have the predict model. So the train model basically goes through machine learning and and from historical data understands the dependencies and thus helps us to get to the probabilities of an event occurring as positive or not in this case. We spoke about the drag and drop functionality. All I've got to do is bring in the naive-Bayes algorithm training model. I have the data which we just considered in this table, and the results will be stored in this table. Well, this result will actually be a model output out of the learning that happens by going through the algorithm. As an end user, all I do is I understand that I need to actually get the probability of whether the marketing leads that have come in which would be the most positive, and therefore further score or rank them and mobilize my sales team accordingly. What I see right now showing up is basically the column which actually has the outcome, positive or not, and the other factors which affect them independently. I then have the table that will store my model. Once I have this connected, I need to activate it so it's available for enterprise-wide use. I would then run it, and you will notice that it runs with a SQL procedure embedded within HANA. This further generates a model which is used, and the model can be seen here. So this is a model which is basically factoring on the conditional probability that needs to be taken into account, and therefore when new data set is put across this model to find out which of them will be most positive and which of them will not. To apply that, I have in the same library the predict model, which is here. For time's sake, I have connected it already to the data which needs to be predicted, and the model output itself, which we considered in this part. This would give me an output of those marketing leads which are most promising. In this case, it would be a yes or a no, and that could be taken further exploring. So once this is run, which I've already pre-run, I would then be able to go and I've created a view between our previous data and the data of the prediction, which comes from the same data store. And these are our marketing leads which have come in, the new marketing leads which have been passed through the same predictive model. And when we move on to the right, of course, we really do not know as of this point whether they are customers or not, so this column is going to be empty. But then the predictions that we are making is either it's likely, most likely, or probably not. and then we could go after those that are most positive. So here we have an example where, without fully understanding the science behind predictive analytics, any business analyst can get their big questions answered. The business value in this is the ability to deploy complex algorithms to work and answer your business questions by any user in your organization. Well, when we consider predicting and using predictive algorithms, we also look at machine learning that plays an important role. The records in business databases are usually not directly ready for predictive analysis. Oftentimes, there is a need for data pre-processing so that it would fit the input of a particular algorithm. Some data contains noisy observations which may hurt the accuracy of an algorithm, while some attributes are badly scaled, which can make an algorithm unstable. One such factor of particular significance is to ensure that there are no holes in the data, that there is a value for all your rows and columns before processing them through a predictive algorithm. So here we have data that I have from marketing. Well, this is a survey to find out what has been the response of our customers to products that are out there and they are using. And there were a set of 10 questions on a rating of 1 to 10. They would actually provide their ratings. There's also asked from them the gender, so to help classify observations based on age groups and between genders, and also their age for the same reason, so we could see what is most popular among the age categories that we classify. Clearly, all this data does not have all the required input. While we do see that some of the inputs are complete, like these rows, some of them are partially complete. It is in our interest to be able to consider the valuable inputs that have already been provided. But factors like these, which do not have, like people could keep from mentioning their gender, or people are sensitive about their age and they wouldn't put it down there. Things like these need pre-processing before we put them to algorithm. SAP provides this functionality of pre-processing within the same interface. So here I have an algorithm which substitutes missing values. So what it would do is it would take the data that was coming in, and before it is set out to be processed by other algorithms, it would make sure that it is ready for the algorithm to be used. Once we run this information, runs the incomplete information through this model, we would get an output with the complete information. So let me move on. So I've run it, and then I'll go to the predicted results. Well, basically the filling in of missing values and its results. Give me a moment here. Okay. These results are stored in the data results. That is here. And they're here. So we have the initial inputs which were incomplete filled up in this case. So we have no holes in our data, and this can be used for the processing. What algorithm does is it employs a mean, so it's an arithmetic mean for the ratings. So it checks in all the values in the column. It basically arrives at a mean to fill up the gaps which are available. This is because we would like to use other ratings which are genuine and complete, while we would not want to ignore the rows completely just because one of the ratings is not complete. What it does for the age is it goes and checks the median value. So it actually goes in through all of the values that are there and dynamically assigns a median value to those that don't have values. For the gender, it goes by what's most occurring and therefore fills in the gaps. And this algorithms like these and others that are available quickly in the same interface for use are made available so that you can prepare data for your model without needing to have separate tools to come in. For those that require advanced modeling and for those that require data cleansing, you could use tools that actually are within the BizFabric portfolio. Data service is one of them to actually cleanse your data. But if your transactional data in SAP systems is residing in the same environment, then most of it is already available for you to use. While working with predictive analytics, the factors to be considered are not only data quality, but also data volume. While applying statistical techniques, there is a need to deal with the huge volumes of data. As discussed earlier, SAP Predictive Analytics with SAP HANA combines the depth and speed of in-memory analytics with the power of native predictive algorithms that sit side by side within the same database. So in this case, we would like to classify transactions. I would move on to particular algorithm that would help us classify transactions based on their percentage share contribution to revenue, customer credit back, quantity shipped, and quantity returned. So what we're doing here is we are passing millions of rows without any aggregation right to the item level through the predictive algorithm. In the first case, we would like to specify and basically classify all transactions that contribute to 50% and more of the revenue as Class A. Those that contribute to 30% of the revenue as Class B, and so as Class C. Those that contribute 20% of the revenue. What we also do is any credit backs that have occurred also need to be scored. So those that fall into Class A are those that have most been credited back. The customers have a credit back. 20% and 1% as Class C. Similarly, on the quantities sold, the same data is put through the algorithm to be able to find out its share for getting to the fast-moving products, and how many of these products have been returned back. So as you see, I'm easily navigating between the screen, which is the modeler screen here, and the properties and the logs that are down, which is available in the system. I haven't moved out of the screen at all, and I've been there to be able to navigate through all of this in one place with my data stored in the same environment. So what we're going to do now is we're going to pass, and these are millions of rows, parallelly through the same algorithm 4 times over to go through an iterative process and be able to come out with the classification of A, B, or C category so that we could further run any specific sales promotions, say to a customer who are buying those products, or we could look at those products which are fast moving and shipped out versus those that are returned and further investigate the reason for return to improve on quality. I would run this just to show you the execution capacity and the available in-memory computing that is parallelly placed side by side. So we're looking at about 4+ million, more than 4 million rows processed iteratively through the 4 parallelly at the same time within 6 seconds. It's less than a second for processing, and I say that because it's not just a million rows going through one algorithm, it's 4 of them separately, parallelly going through at the same time, going ahead and classifying. So you see the power of in-memory computing, which is made available for predictive analytics, which is very essential in the HANA environment. Just to elaborate on that a little further, I have data on that, which is built, so that we could just take a look at the result itself. And so if I go to one of them, okay. Take a look at this. All I'm doing is I'm looking at the revenue contribution right now. So just looking at what is the contribution. I'm just going to separate this so it's easy to see. So we see those that have contributed to 50% are Class A, and you can look at the amount of rows that have actually been processed within seconds. And this is 2 million plus. And then you have those that are contributed to Class C that have contributed to 20%, and Class B, those have contributed to 30% of the revenue or more. Like we discussed, this can be used for further targeting customers who are buying those products so that we can offer them sales promotions, or we could go after those that are most return to investigate and improve quality. And this is on unaggregated data. We will now take a look at a scenario related to pricing within the retail industry. I would move over to a screen here, which is created using SAP Lumira, which connects to transactional and predictive data stored within HANA. What we see here is that the vendor has quoted a price raise in the cost of soybean oil. So I could just click on here, and this is the report, which is connecting, and the data connecting real time to the SAP HANA database and providing you with the information that is required. And it's a report which is readable for executive management. So we're looking at a vendor who is reporting the price raise, and there's a certain percentage raise in the price. So there's going to be a new price, and there's going to be a change of about $3 or so. As this calls for a price revision for the finished goods that use soybean oil as a raw material, the immediate question would be, what are the finished goods that consume soybean oil, and what is the quantity of oil required to manufacture those products? We very well have this information in the bill of materials and can list out all finished goods which consume soybean oil. This is part of traditional reporting. Questions could also be to understand what are the incoming customer orders for these finished goods, so that we get to know what is the demand for these products in the upcoming month. So here we have the demand in cases and the consumption that it requires of soybean oil in tons for different material groups, which is here grouped out and laid out onto this scale. And this is available from the transactional information that's available to us connecting to the same data store. And we would also like to know the additional cost of procuring soybean oil supplied to the various manufacturing plant locations. And we could very well do that with connecting to the information we have on soybean oil, which have already been planned to be provided to the different plants, like we see here. And we can take a quick look, and this will be refreshed depending on when data changes. So there is no need of recreating a report once it is set up and connecting to the same database. So what we get to know here is that the demand of soybean oil at manufacturing plants is about 40,000 tons, and the additional cost that would be incurred because of the price change is about $350,000, a little more than that. So when it comes to ensuring that our profit margins are maintained, we could take a simplistic approach and relay the cost of production to the customers without considering the impact this could have on sales revenue. It would logically imply that if you pass on the cost to the customers, you would continue to maintain your profit margins. However, what if, due to the price increase, there is a decline in the sales revenue, simply because the demand for those products among consumers declined? At this point, the business question which arises is, how do I manage pricing and retain customers to maximize sales revenue? We also realize that traditional tools for analytics are limited, and there is a need to employ advanced analytics in order to predict the impact of a price change on sales revenue. So this detailed report provides price recommendations which are arrived at by using the regression algorithm within Predictive Analytics. Mathematically, we could represent the equation for use for regression in this case. Here y is the independent variable, and in this case, it is the dollar value of sales revenue. x1, x2, and so on till xn are independent variables which influence sales revenue. The most significant independent variable is price. In this case, x1 is price. We have promotions which is a percentage discount provided on the product, This would be X2 for our promotions, a score. X3 is the score on display provided at a store level, depending on how well the product is represented to customers. Other factors would be a score on location. Some products like cosmetics would sell better in stores located within a mall, but for daily necessities like eggs or milk, you would go to the nearest available store. We also have competitive price, which could affect the sale of our product, and hence we factor in at least 2 such prices as independent variables in this equation. The coefficient alpha represents base sales. The coefficients beta 1, beta 2, and so on represents the coefficients of the respective independent variables. Our aim is to understand the sign and the magnitude of these coefficients from historical sales data to be able to understand how much of these would affect the independent variable y, which is the sales amount, if any changes are made to, say, price, x1, or to a score on promotions, x2, or the other factors. If the sign of these coefficients is negative, then the relation is inverse. So raising the value of the independent variables would result in a decrease in the value of y. In this case, a price increase would result in a decrease in sales. However, it is also important to understand the magnitude of the coefficient. If it is very close to 0, then it would have a relatively lower impact. The predicted value of y could be determined taking into consideration a combination of applying the coefficient values obtained by running past sales transactions through the regression algorithm. So here we have the data with past sales transactions. We run it through the regression algorithm. Now, we also have here very easy to use functions like filtering, aggregating. You can drag and drop the data template right here for storing your results, which come out straight out, and you don't really need to go in and define it by coding or even by using. You can use SQL coding, but you can also use the drag and drop functionality by just, like I've done in this case. These have just been dragged and dropped here, and when you connect them, they align to the structure that is being delivered. So in this case, the results will be stored here. The fitted data, the significance would be stored in these tables, and you don't really need to define them programmatically. So by making changes to the independent variables, basically in this case, we are going to use this regression algorithm, which is filtered to a material at a material level, to process historical sales data to obtain those required coefficients that we were referring to. So these values, when passed through the algorithm, are available for view right at the report level. So I could then go ahead and check and see the variables. Here it's filtered to the material. So we're looking right now at a 12-ounce regular ranch. It's one material, and we're looking at what are the coefficients for them. And we see that there's a very high value in terms of price, which means this product is very price sensitive. So by making changes to the independent variables, in this case for price, would have a greater impact in the sales revenue coming down. But this is an iterative process of passing new values to the equation, so to obtain the predicted results, so you can get deeper insights on the changes in sales revenue. So say there was an increase also on a similar magnitude of a vendor bringing up its price. In that case, even though you increase your price, you would still be okay and not bring down revenue, because there are other factors as well that contribute, or you can improve its display or its location. But in this case, it does show that this particular product is very price sensitive. So going through this process, we have the new prices that are recommended for each finished good. So when we move down of the report, we have the price recommendations, and we see its impact. We could bring up the report and look at it by material and filter it further. Now, in this case, if we see the price of salad dressing, you see that the price is changed, and these are prices per case. There is a negative impact on the sales revenue identified by the value here. So the line here is positive, but the one that comes here is negative, and then you have the others as positive. So there's a negative impact on the sales revenue. This is because customers use this product on a daily basis and are very well aware of the minor changes in prices. There are other alternatives available. So in this case, in this particular scenario, we have not altered the independent variable except increase the price. So we see a decline. But it gives us an indication that this particular material finished product is very price sensitive. So to the extreme right, we see that cosmetic products like skincare items are not as sensitive to price variations. Consumers do not buy such products on a regular basis. Hence, their response to a slight raise in price is not negative. Also, if certain cosmetic items suit them, they would not mind to pay a slightly higher price for it. So we get an indication when we run what-if scenarios within Predictive Analytics to be able to arrive at this result as to what will happen if we raise our price and how much it would impact. Patterns like these help in gaining insight from past data to determine what will happen in the future if these changes are made today. We can go one step further to compute the price elasticity of these goods. So the price elasticity of these goods, usually a very well-known term used to gauge the price sensitivity, or basically how much it would the demand or the sale revenue in this case would change depending on an increase in price. So, and it's calculated by the percentage change in sales in this case divided by the percentage change in price. This calculation would provide us an insight into the impact of price a price change could make or could have on a product. Here in the same report is a ranking of calculated price elasticity of products. The more negative numbers show higher or greater sensitivity to price change than others. This would go a long way to make decisions knowing predicted outcomes and calculating the risk that we need to take in terms of price increase and take a more calculated approach before making decisions. So we see that at one place, I get to see my transactional information, which is coming in from my day-to-day transactions that are happening, to moving to an advanced analytical solution to be able to recommend prices or at least and take a look at what are the impacts that these changes have made and what I could foresee already today what would happen in the future. And can I make it better by improving certain parameters? Can I work on others so that I can still work and ensure that maximum revenue is maintained and our profit margins are kept the same, and are there any avenues to increase and better them? So this is an iterative process that goes through a learning cycle of learning from past information and then predicting, and then we go back and change the parameters, and we come back and we check on what impact it has, and this is how we actually arrive at the best predictions. We can use these algorithms natively available, and we can actually run through huge amounts of data through these algorithms without worrying about how much of transactional data we are actually. And the more the information, the historical data, the better the predictions would be, because we are taking a larger sample of data into account when statistically looking at these, using them for predictions. So in the market, we have materials which could fall into the categories of being either perfectly elastic or relatively inelastic. In cases like these, increase in price results in the increase in revenue. Well, products which fall into this category have very few alternatives. Example, insulin for a diabetic patient, or gasoline for that matter. There are unit elastic products which belong to this category are those for which a unit increase in price or decrease in price would result in the same increase or decrease in revenue. And for most of the products that we actually took a look in our example, or the ones that fell into the relatively elastic category, where the product which belongs to those that have competitive alternatives and are available which are available in the market, and customers could switch to other brands easily. So, which means that a rise in price would have a greater impact and decrease in the sales revenue. And we need to take a calculated approach and have a well thought of and foresee the results that could come in and work on it already today. When it comes to understanding the significance of the model, where in this case, regression, there are two parameters used in linear regression. R-squared value, which is the measure of how useful a model is for prediction. This value ranges from 0 to 1. The closer it is to 1, the higher is the confidence one can place on the predictive model. F is of statistical importance, which takes into consideration the size of the sample data used for generating the model and the number of independent variables used in the equation. Higher values of F are desirable for predictions. So together, they help evaluate the significance of a predictive model. So with that, I pretty much come to the end of my presentation. We could probably take in questions at this time.
Hi, George, can you hear me?
Yeah, I can, actually.
Okay, wonderful. I was just about to cut it and ask if you were able to wrap up in a couple of minutes. We can get to some of the questions. Okay, let's see what we have here. One of the questions asked by a participant was them wanting to know if the models created within HANA are reusable.
So within HANA, yes. Well, the answer is yes, it is reusable. Now, within HANA, once you activate the model, it is available enterprise-wide for all users who have access to it. They will be able to use it. If you are talking about other applications outside, basically, which would like to reuse the predictive models that were created within HANA by using the SAP Predictive Analytics library, you have the option to export the model information into a local file in the industry standard PMML format, which is known as the Predictive Modeling Markup Language. And then you can further share this model with other PMML compliant applications to perform analysis on similar data set.
All right, great. We can take another question, and that is, what should business focus on while choosing between available predictive analytics software in the market?
Good question. I think it depends on how you would like predictive analytics solutions to work for your organization in the long term. So certain key components or certain key considerations would be how flexible is the solution to be integrated within your current business process and landscape, and also how scalable it is. Or does it require business data to be passed to and from the application while arriving at predictive results? This would involve increased complexity from an implementation, maintenance, and even a governance perspective. Another important factor would be to check how well the solution handles big data, which is huge volumes of data, as this would be a key to avoiding most performance issues. I hope that answered the question.
Okay, George, that's actually all the time we have for today. To all the participants, in regards to the questions that we couldn't get to, George and Rob will be contacting you via email to answer the submitted questions. We would like to thank you all for joining us today, and the webinar is now concluded.